and welcome to this TouchDesigner tutorial where I'll be taking you through making a realistic texture like this spinning object here on our left out of a just a 2D image. I mean, this is all I use to kind of generate this. So I'll be taking you through this process here. So let's get started. If I bring up this new TouchDesigner network and I just get rid of everything in there, we're just going to start from scratch and add a movie file in, which is going to be our texture. And I use your own texture. Use something that you find on the internet. I've tried this with these stones and a wood floor. I've also tried this with just a straight brick texture. And it works for all of them. You just have to kind of tweak and dial it in. But the general process is always kind of the same. So I'm going to take my movie file in and place it in my network. And next I'm going to create a render network. And this is gonna be used to kind of show off our final texture in here and kind of tweak some values to get it right. And let's get rid of the torus. It's kind of hard to see what we're doing here on the torus, but this should work for pretty much any geometry you give it. We're gonna do ours though. We're gonna create a sop in to a null, connect the two, and then turn on your render flags in that null. So now whatever we pass into our geometry, such as a grid, for example, which we're going to place in, will now be rendered. Great. Next step, let's set up our material. So if you go into the mat and you look at Phong, this Phong material is actually the exact same thing that's applied right now ambiently to our network. So if you drop it in as your material, nothing really changes. However, if you start to play around with some of the stuff in here, like the diffuse values, you can see that the lighting has remained, and you can play around with specularity. And Phong is a really great texture or material to use because you can play around with so many different options to kind of narrow in exactly what you want. But we're going to be using it for one of its very special features, which is normal map. And we'll get to that in a second. But first, let's just apply our movie file in. We'll create a null, top, and we'll apply that as our color map. And if you look at your geometry, you'll see that that just appears, right? Like that image just gets transplanted onto that geometry the exact same way we see it over here. But if I were to move my camera around, like make my geometry, constrain my camera to look at my geometry and move my camera around, you'll see that, you can't really see the rocks, right? It just kind of like looks like it's painted on the wall. It doesn't really look like they're coming out in any way. So let's fix that, yeah? And the way you do that is by from your movie file in, we're going to add an operator called normal map. And normal map is going to generate a very specific type of 2D image, which allows the material to break down edges. So if you look closely here, you'll see that this side of this stone is cyan and this side is more purple. Well, the top is a bit brighter, like whiter, and the bottom is a bit darker. And this kind of denotes the edges of these rocks, right? The normal map looks for a contrast and then creates the sides. So if we apply normal map to our Phong parameter, something changed in there. You can definitely see it. And then if you play around with the bump scale of normal map, you can see something cool happening. You start to kind of get the sense that this billboard has depth, right? If you play around with this enough, you can kind of see it going in, right? Like all of those creases where the cement would be are going into the texture. Pretty neat. And I mean, if this works with a light, right? Like that's the cool thing about it. If I start moving my light around in here as well, right? If I kind of float my point light a little bit off my texture and move it around, you can see that the shadows and the highlights kind of move with this light. And to give you a better example of this, I'm going to create a circle sop and add it to the path parameter of my light. Get rid of any translate that I might have on my light right now. And step my circle sop out in the Z direction a few points. Then animate the position of my light in that path with abs time dot frame divided by 200. You can see that the light is kind of now moving around this billboard, and if you look carefully, you can see that highlights are picked up on rocks in the direction that the light is moving around, and that's the result of the normal map. If we were to not apply a normal map at all, you would just see that light kind of like lighting up those rocks, not really applying the specularity to the edges, which is kind of what we're after. And as you play around with the bump value, you can see that shifts and changes. That you get more of that or less of that, or you pick up more of those little tiny indents and nooks and crannies or less of it. So playing around with that on an image that you're never going to really approach with a camera is a really great way to save cycles and still get great looking imagery. But like I said, you can't really approach it with a camera too much, because if we look at this from a steeper angle, you'll notice that it's not really bumpy. It's a trick that we're playing. It's only at the image level. It's not at the actual geometry level. We're only sending back the light that hits that particular part of the image back to our camera, and kind of cheating in creating this texture. So really great if you know your camera is never going to look at any other angle of your geometry, but you know, kind of ruins the effect the second you step outside those few degrees of freedom you have. But we can fix that. And there's a really great way to fix that, which we're going to kind of create our own, well, we will be creating our own DIY displace element. And the reason I say DIY is because programs like Blender or Cinema would have this kind of installed, but Touch lets us have a lot more control over what we're doing. So let's get started with that, right? We want basically the end of this little chain. We're going to have the ability to push one of these rocks out. So let's create a new null from our movie file in. This null will go into a fit, and the fit resolution will be directly driven from our grid's rows and columns. So I'll use the expression op grid1 dot par dot columns for our x, and op grid1 dot par dot rows for our y. And then I'll fit that fill, right? So fit to fill. After that, we're going to create a monochrome texture, or top, and we'll take that into a blur. Then we'll take that into a level. then we'll take that into a null. Nice, really long chain of operators that do a lot of different things, and we'll see what they do in a second. But for the time being, just trust me that we're going to need them. Great. From here, we're going to move all of this stuff over so we can kind of keep our network a little bit organized. From this null, we're going to create a top to chop, where we'll get all of that pixel information as chop data. And right now we're taking only a single slice across this image. In this crop menu, you can see that. We're only taking a single slice of pixel information that's across the image and displaying it here. And what we really want is the full image, which is going to, you know, kill our FPS for rendering it. So if we just turn that off, we'll bring our FPS back up to 60. Next, we're going to take this top two into a shuffle to separate out the red, green, and blue values from all of this mess in here. So in shuffle, the method is going to be sequence channels by names, and we'll get RGBA, which is all of the pixel information up here. And all of these are exactly the same because we sent it through this monochrome up here, upstream. Or, yeah, there, that monochrome. So all of this pixel information is the same. So really what we're after is just one of them. So I'm going to create a select, which selects one of them out. We'll say R, and we'll rename it into TZ. We're then going to take TZ into a math chop. So select into the math chop, so we can range this a little later. And then the select, the math into a null. And this null is going to give us that displacement information. It's going to allow us to push this stone up, you know, or all of the stones. So we're taking a luminosity value of this image and giving that as a depth value now. And if we go into chop 2, if we create a chop 2 in our SOP stream here, and pull null 4 into that chop 2, we'll see that it's still broken, and the reason that's broken is because this is actually expecting 3 values. So if we feed it in only 1, TZ, then in the P attribute, go P2, which is the X position of our, the Z position of our points. We've now manipulated this geometry in some way, and you can see it here if you rotate that around. What's happening is all of this has been pushed up to the top, or you know, basically the extent of 1, right? So that's what this math here is for. We want to center it on the origin. We don't want it pushed away from the origin. And to do that, if you go into range and then select the to range and make it -0.5 to 0.5, that'll place it right on the origin. It'll hover over there and kind of be a little bit more tame. And now if we move our camera around, you can see that we have some bumps. That's awesome. But they're not really lining up with our stones that much. You know, they're kind of they're interesting. They're definitely 3D now, but and if you kind of, you know, are zooming by, that might work for you, that low poly count. But say you had some kind of detailed examination of a wall, you don't really, this isn't really working for you. You're not really seeing the grout in here or any of the individual stones by themselves. You're kind of seeing these big lumps that could be stones. So not really accomplishing what we're after. So how can we get closer to seeing individual stones and seeing the grout kind of by itself? Well, that's what this level was put here for. The level, you can control the black level, which will kind of control your bump level, right? So you can play around with this a little bit and see if that will help with whatever texture you have. And you can see kind of what that's doing, right? As certain pixels intensities get brighter, we can see that our bump level changes. So that's great, kind of helpful. But what you might be thinking is that this blur is damaging this, right? It's kind of giving us these really kind of gradual gradients. And if we bypass that, you'll see that that's really not the case. If we were to send the pixel information by itself, we'd get these crazy points that aren't really useful. So this blur is actually doing quite a big deal. And if you play around with it at all, you'll see that you're still getting that, or you're getting, you know, worse of a gradient. So how can we fix this? I mean, I really want to see these individual stones popping out of this grid. Well, the only real way to fix this is to give yourself a larger resolution to work with. Right now, we've only got 20 points by 20 points, which is, you know, 400 points of information to fit across this image that's actually, you know, significantly greater, 900 by 675. So if in your grid you bump up your resolution, you subdivide your grid to a larger extent, like let's say put the rows at not 1 but 100, because we reference that in our fit, our image can now be that large. And you can see that our level is actually doing something really exciting here, where it's picking out just the stones. And if we manipulate this more, you can see that I'm pulling those stones out of this image, and that's pretty exciting. So yeah, I mean that's the stones kind of popping out. And now if we manipulate our camera a little bit more, you can see, oh my God, they're mountains, they're not stones. We can see though that those individual stones are there, right? Pretty awesome. And now a way to fix this kind of like mountain effect that we have going on is in your math. If you take your math and you instead of ranging the full 1, you range it, you know, half that, you can kind of start to limit that bump scale down to a more manageable level. Yeah, that's looking a little better. Another thing you can do to manage that is in your blur. If you step up your blur, you can kind of control that as well, how much of a gradient those things get, so they cannot be so insanely high. So this is starting to look pretty good. I mean, this is starting to look like a jagged stone wall, which is what we were going for. You can see individual kind of stones there, and if we play around with this black level, we can give more of a contrast to them. You know, and this is kind of like where the design tweaking comes in. Like, how much of those stones do you want to see? Is it really important that they're all kind of out there? You know, it's all stuff that you can play around with and see if it's really helping. The very last thing to do, you can kind of see that this isn't happening though. We're getting a lot of highlights, but we're not getting a ton of shadows, which is a little unfortunate. This would look really great if it had some better shadows to it. And there's a few ways of doing this. If you step up your normal bump size, you can start to like really get into this gritty territory where this looks a little better. And in your Phong, if you turn down your shininess, your rocks stop to look, you know, like they're wet or made of gold or some kind of crazy metal, but start to look like they're actually kind of, you know, not slick. The last thing to do though would be in your Chop 2 to compute normals, and that'll give you like these shadows. And this looks a little ridiculous right now, but the shadows will definitely help you kind of see those bumps a bit better. and you can futz around with this. You know, your bump map might be throwing that off, or in here in your level, if you kind of try to equalize that playing field a bit more, you can work with that. But you know, this is the basic setup to create those kind of realistic looking textures. You know, you grab the height data from luminosity and you feed it into a chop2, which displaces the geometry. The last thing that I would probably do with this is fix the size of my grid to be 4:3 like the image, and then probably zoom my camera out because this is really close. And this is looking a lot better already, just being able to be a little bigger, and the light and the scale just kind of helps a bit. And if I were to move my camera around, you can tell that that's protruding, and it's a nice looking stone wall. I'd kind of believe that if I were sitting in an Oculus Rift or a game, I'd buy that as stone a lot sooner than I'd buy that flat image of stone. So that's the basics of how to do that. If you have any more questions about it, feel free to comment on the video, or comment on my blog. Until next time.